All right. I think this is day 4. Um, I want to first off by saying thank you to all the people that subbed and that viewed my story. Viewed my videos. It's insane. I one of my videos almost got 500 views and I gained like at least 25 subscribers the past 3 days, which is insane. So I want to start off by saying I appreciate you guys for the support and stuff. So yeah, I just wanted to show you guys. Here's the videos. They went insane. So I really appreciate you guys. I want to just start off by seeing the comments. If we have any comments, it's not letting me see these comments, but just want to reply to some comments. Super cool. I think I'll reply to comments after, but yeah, but man, I really appreciate you guys. Like, it's so insane. I don't know how the hell just popped up. Got a couple of views. 3. Like, insane. But I appreciate you guys. Yeah, I almost started this problem. Honestly, I forgot to do my video, and I was just gonna do this off YouTube, and then I was like, holy shit, I gotta do my video today. So I started a little bit on it so I could just restart, I guess, and tell you guys my thought process. I didn't even finish it. I was just like halfway done. Yeah, so today we're doing twosome. I think everybody knows what twosome is. Give me 1 second. I got a notification. You turn these off. I don't want nothing popping up that shouldn't be popping up. Okay. Cool. Yeah, we're doing twosome. I think most of everybody has done twosome before, but yep, twosome. Given an array of integers nums and an integer target, return the indices I and j, such as nums I plus j equals target, and I does not equal j. Oh, okay, and I does not equal j. Yeah. So I kind of started the problem a little bit. I don't know if I'm doing it right or wrong, but the way I was doing it was so I'll tell you guys my thought process. I was doing a four index. So I was trying to find the indexes, find the index, and then each index you add it to the number. If that makes sense. Thing is, there's a problem. Okay, well, let's just do what I was thinking. For index, if we want the indexes, we have to do range nums. I would need to do len though, right? Okay, let's just do nums is equal to 1, 2, 3, 4, and what's the target was it called? Target is equal to 1, 2, let's just say 7, and let's do 4 index and range nums. If I print this should show an error. Yeah, so we would have to use len here. Right, we get the indexes now, so we would have to use another parentheses and we'll use len. After that we would do Let's see. So then we need to do a for now we need the number for number. We can just say num in nums. We want to check if the index. So we do nums. Is it nums? It is nums. Nums, the first index plus. Fuck. There has to be an issue here because we're adding the same number, huh? Okay, before I do this, I like to keep my shit clean so I know when I view it. Is equal to the target. We want to return the nums index. Holy moly, that's not what I wanted. The nums index and the num. Holy shit, I can't fucking see my screen. Yeah. Holy moly. Oh shit. That shouldn't be what is happening. This has to be wrong. Type error. Your output was but expected value type was list. Type error. Your output was 3-4, but the expected return is list. Oh. Well, what the fuck, you want to do this? Oh, he wants the indexes? Hold up, we might be right. We just need to return the indexes. So I can just return the index here. So I think we just do the opposite, no? I might be wrong. Nums. Num. Holy shit, what is wrong here? Oh, there's an extra one right here. List index out of range. Num. Oh. What if I just return the num? Yo, just return 4. Your output was 0 for. Holy shit. Hold up, wait. We have the index. How the fuck do I get the index of that number? Bro, I have to do 2 range lens? If I put num, obviously it's gonna be 0-4. I just need the index. I need this. How do you get the index from here? If num's the index, don't think this will work. Would I have to get the index of the next one? Would that make sense? Holy shit. Fuck. Hold up, I did something wrong because shit. I can't equal J. Holy shit. Nice. It can't equal each other. I forgot that I did this situation. I did this, but I forgot that the indexes can't equal each other. What are we thinking? Come on. Come on, you guys are seeing my thought process out loud. This is probably the most shittiest way to do this. I need to start doing like data structures like bad. I didn't even do no hints, by the way. No fucking hints. Y'all saw that. I did no hints. I tried on my own a little bit, like literally a little bit, but I didn't do crazy. Index to iterate on. We can iterate through the indexes I. The difference. Hold on, yeah, we're gonna watch this video as well. So, holy, a noogler. 8-minute video.
Let's solve LeetCode 1 twosome, the most
Let's watch this video,
popular
boys.
LeetCode question. So we're given an input array and some target, in this case 9. And we want to find the two values in this input array that sum to 9. So in this case, it's 2 and 7. Now we want to return the indices of these two values. So the index of 2 is 0, the index of 7 is 1. So we return 0 and 1. We're guaranteed that there's exactly one solution, so we don't have to worry about not finding a solution, and we don't have to worry about multiple solutions.
I think what I did wrong was, I think I was going too fast. I really didn't read the question right. Like, I understood it because I saw this a minute ago, but I didn't. I went too fast. But as you can see, this is the example that failed me hella times. Yeah. Yep. But the way my thought process is, the way I solved this was, you get the index of the nums first, then you get the next index of the nums again, then you add the first index with the next index, but they cannot equal each other. The indexes cannot equal each other, so you would have to go to the next one, and boom. This is probably the most shittiest way to solve twosome, but see how.
Let's solve LeetCode 1 twosome. Efficient. This is basically brute force.
I think I went too fast.
Including 1 that sums up to target 4. So we scan through every element that comes after it, 5 and 3, and we find that 1 added with 3 sums up to our target 4. Notice that we didn't have to check the values that came before 1 because we already checked the combination 2 and 1 when we were up over here. Remember when we checked every combination with 2? So we didn't have to repeat that work down here. We only had to check the numbers that came after 1. So the runtime of this algorithm isn't super efficient. This is basically brute force. We're going through the entire array of length n, and we're going to do that worst case n times for each number. This means that overall worst case time complexity will be O of n squared. So can we do better? Now the thing to notice is that for each number, for example 1, the value we're looking for is the difference between the target and this value 1. So we're looking for 4 minus 1, which is equal to 3. So that means this is the only value we can add to 1 that'll equal the target. So we don't have to check every number, we just want to know if 3 exists. Now the easiest way we can do this, the most efficient, is by making a hash map of every value in our input array so we can instantly check if the value 3 exists.
Holy moly.
Now let's try the same problem, except let's use a hash map this time. Now in our hash map, we're going to be mapping each value to the index of each value. So the index of 2 is 0, the index of 1 is 1, the index of 5 is 2, the index of 3 is 3. So in our hash map, we're going to be mapping the value to the index.
The value to the index. Right.
Now we could add every value in this array into the hash map before we start iterating through it, but there's actually an easier way to do it. If we added the entire array into the hash map initially, then we would get to the value 2 first, right? We would want to check, does the difference between target 4 minus this value 2, which is equal to 2, exists in our hash map? And we would find that 2 does exist in our hash map, but we're not allowed to reuse the same one, right? Because they're both at the same index, we can't use the same value twice.
Right.
So we would have to compare the index of our current 2 with the index of the 2 that's in our hash map. There's actually an easier way to do this though, and it's a little clever, and let me show you how to do it that way. So doing it this clever way, initially we say our hash map is empty. So we get to the value 2 first of all, right? And we want to look for the difference 4 minus 2 in our hash map. Our hash map is empty, so we don't find 2. So then after we've visited this element, then we can add it to our hash map. So now that I'm done visiting it, I'm going to move to the second element 1. And before I do that, I'm going to add this value 2 to our hash map, and the index of this value is going to be 0. Now I'm at 1. I'm looking for 4 minus 1, which is 3. I see 3 isn't in our hash map, but it actually is in our array. So what's the problem? Well, for now we're going to say we don't find a 3. So we add 1 to our hash map. The index of this 1 is 1. And now we move to the next element 5. We check, does 4 minus 5 exist in our hash map? That's -1, so no, it does not. Then we add this 5 to our hash map and its index, which is 2. And we move to the last value in the array, 3. We check, does 4 minus 3 exist in our hash map? Now that's 1, so we see it does exist, right? Right over here. The value exists and its index is 1. So now we found our 2 values that sum to the target, and we want to return their indices, which are going to be 1 and 3. So with this algorithm, we don't...
Hold up. Let me get this right. The way he's doing it is he's getting the target. He's getting the target, subtracting it by the values, and seeing, does that exist in there? And if it does, how do you even think of that? Boom. It doesn't exist. Put it into the hash map. Target minus the value. 3. Is 3 in here? No. And then 4 more. No, -1's not here. Put it in there. And the index. 4 minus 3. 1. What the fuck? Two minus 9. No, is it 9? Yeah, 9 minus 2 is 7. That's not in there. Target to get to 9 is 2 and 7. 9 minus 7. 2 is 2 in there, yes. So those are the two. What the fuck? How do you even think of that? Dude, on God? That's crazy. I don't know if you guys are even like baffled as I am. That's insane. That's actually insane. I swear to God, I would never have think of
Don't
that.
have to initialize our hash map. It can be initially empty, and then we can just iterate through this array in one pass. Now, the reason the algorithm can work in that way with just one pass is this. So let's say we had a giant array, right?
Right.
We know for sure that there are 2 elements in this array that sum to our target, right? We don't know
Right.
where they are. They're at some arbitrary location.
Right.
When we visit the first one of those elements, our hash map is only going to be this portion of the array. It's only going to have the values that came before the first value. So we're gonna notice that the second value that can sum to the target is not going to be in our hash map yet. But once we get to the second value, our hash map is going to be this portion. So every value that comes before this, right? So we're going to be guaranteed that once we visit the second element that sums up to the target, we're going to be guaranteed that the first one is already in our hash map, so we're guaranteed to find the solution. Now, since we only have to iterate through the array once, and we're adding each value to our hash map, which is a constant time operation, and we're checking if a value exists in our hash map, which is also a constant time operation, the time complexity is going to be big O of n. We are using extra memory, right? That hash map isn't free, so the memory complexity is also going to be O of n because we could potentially add every value to the hash map.
Right.
So now let's code the solution. So remember, we need a hash map, right? I'm going to call this previous map because it's basically every element that comes before the current element. Every previous element is going to
Damn.
be stored in this map. We're going to be mapping the value to the index of that value. So now let's iterate through every value in this array. We need the index as well as the actual number. So let's do it like this in Python.
Damn, so I could have just... I don't know if you guys are like, you found out what I did that is kind of stupid, that I just, reading just one line that I could have done is, I literally could have just put index num and just do the if statement below there. I'm guessing that would work because it's doing the same shit.
Before we add this to our map, let's check if the difference, which is equal
Damn,
to
I
the
never know.
target minus n. Now let's check if this difference is already in the hash map.
Fine. If diff, so diff equals target minus n. Right, that's what he did over there. If it's already in there, return I and n. Else, add it onto there.
If it is, then we can return the solution, which is going to be a pair
I and n.
of the indices.
Oh, yeah.
Sorry.
So you got to do a return previous on a diff I.
You can get the first index like this, and the second index is just I.
Yeah.
Now, if we don't find
Wait. Previous diff. Oh, and I. Right. So. So. Can I see the fucking problem? Damn. Okay, we'll look at it after.
the solution, then we have to update our hash map.
Right,
So
we have to.
for this value,
We'll put I.
n, I'm going to say the index is I.
Yeah.
And then we're going to continue. Since we're guaranteed that a solution exists, we don't have to return anything out here, right? But I'll just put a return for no reason. Now let's see if it works. And it works perfectly. So with this kind of neat little trick with just doing it in one pass, you can reduce the amount of code you have to write and not have to worry about like edge cases and
I ain't gonna lie, man. There was no way in hell, bro, I was gonna guess that's how you solve that. That's insane. That's actually insane. Like storing in a hash map, subtracting the target by the number, seeing if that's in the hash map. If that's already in the hash map, those are the two indices, bro. That's so fucking crazy. Fucking crazy, bro. Alright, let me just do this because ChatGPT is fucking stupid. This code below is how I solved to sum. The image shows how the solution is. Please compare it and explain it. Okay, let's see what GPT says. Your code, brute force. How it works. Checks all possible. Oh, I'm scared. The worst shit. Makes sure not to use the same integers twice. Return as soon as the downside. Inefficient for large inputs. Nested loop. Slow. Fuck, bro. Whatever. Yeah, this is the best. Stores previous values in the dictionary with value key indices for each and checks if target is already in the map. If yes, pair return the indices. Much faster now into the memory efficient. Use hash map cleaner. Yeah, fuck. Well, I guess we solved this problem today, man. Shit. A horrible way to solve it, but it works. Shoot, we're going to mediums now. Let's see what this next one is before we go. I'm gonna do this tomorrow, hopefully. Given an array of strings, stars. Group all anagrams together in sublists. You may return the output in any order. An anagram is a string that contains the exact same characters as another string, but the order of the characters can be different. What? Oh. So act, pots, tops, cat, stuff, hat. So the way we do it is hat has no other thing. ACT, act, and cat have it. But then you're going to return the anagrams, group all the anagrams into a sublist. Damn. That's going to be a hard problem. Holy moly. Obviously this section is going to talk about fucking dictionaries or hash maps, so something with hashing, I don't know. Something with hashing. Linked list. Oh man. Well, I think that's it for today. I think we solved the problem quicker this time, but I don't know. Not a very efficient way. I need to here, I'll go back. There is a section here to learn data structures. So you know what I mean? There's a lot of stuff here. Damn, hash maps is 12? Holy moly. But this would be very helpful to learn before doing all this, but yeah, I'm just gonna go with the flow. It's always more legal to do. I don't know. But anyways, dog. Again, whoever watches this, I really appreciate you for clicking the video. That one video almost has 500 views, which is so insane to me. Yeah, it's super crazy. I really appreciate the support. It's only the 4th day, and hopefully we're gonna keep this going. So yeah, hit the subscribe button, hit a comment. I'd love to connect with anybody that watches this video. And one more thing I just want to say is these links are in my bio on YouTube. So if you click here and you see this link on my page, yeah, you can click this link, and you can join the Discord community. You can see my LinkedIn, connect with me. Would love to connect with you. My Twitch, I stream at least 3 times a week, maybe more, maybe less, doesn't it depends on the week. My TikTok, and obviously my YouTube. So yeah, if you can, please follow me on TikTok so I get to 1,000 followers, so I can go live on TikTok if it's cool with y'all. But yeah, I appreciate you for clicking this video, and hope you enjoyed this stream. Maybe you learned with me, or you already knew but wanted to support. Yeah, I appreciate you guys. All right, tune in tomorrow. Thank you guys.